So, as I said, we've learned how to solve probability problem using three diagrams. Today we will look into two other ways to solve probability problems. We will look into the Venn diagram. And probability tables. First, let's consider that our sample space, what is sample space? All possible outcomes. Let's say our sample space is a numbers between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is our sample space. And let's consider two events. Event A is choosing the prime number. Which numbers are prime numbers here? Yes? One is not prime number.
2, 3, 5, 7.
9 is not the prime. It is
11.
Is 11 in our sample space?
20, 24.
I'll go to you later. And B, event B is choosing an even number. So we have 2, 4, 6, 8, and 10. And Venn diagram, I'm sure that you already familiar with the Venn diagram. You've seen what is that and used it before. So we have this represent the sample space, and that will be event A. This is event B. And here, where they overlap, we put number which is in both A and B. Which number is in both? We have number 2. So what we have here in A, yes, 3, 5, and 7, 4, 6, 8, and 10. And we have, yes,
We put 9 on the outside.
and we have some numbers which are not anyway, it's 1 and 9. So now we have represented this situation using the Venn diagram. So this circle means everything then in the set A. This in set B. Where they overlap, that means this is in both. 2 is in A and 2 is in B. Make sense? Now that we actually list the numbers which are in the sample space. Let's represent it not using the numbers, but how many of the numbers are in each. Set. So we have A, B. How many are numbers in both? We have one number. How many numbers we have in A which are not in B? We have 3 numbers here. 3, 5, and 7. We have 4 numbers here, and we have 2 numbers here. This, we not listing the numbers, we writing how many results are in each part. So, now let's introduce the idea of intersection A, intersection B. Intersection, or you say it's AND. So A intersection B, it means that what is in A and in B. And what so we have only one number in the intersection. This is the intersection. This is the intersection. because this is in A and at the same time is in B. So what will be probability of get A intersection B? Probability is the number of, yes, it's 1/10. Because we have one favorable outcome and total number is 10. Now, this is A only. This is intersection, A intersection B. This is A only. So that is only in A, but not in B. So what will the probability of get A only? How many numbers we have in A only?
3 out of 10.
3. Total 10, so 3, 10. What will the probability only be? This B only. We have 4 out of 10, which can be and must be simplified. So probability B only is 4 out of 10, which simplifies to 2/5. What are the probability of A? When you say probability of A, we're talking about everything that in A. How many we have in A in total? 4. So probability of A is 4/10. Probability of B, which is 2/5. Probability of B, how many we have altogether in B? 5 equal 5/10 or 1/2. And one more thing, that was intersection, now union. Union will be this. What is in A or B or both. So we say that is A union B. This sign means union or means or. A or B. A union B. So what will be the probability of A union B? How many numbers we have in A and B? In A, we have 8. 3 plus 4 and plus 1, which are in A or B or both. So we have 8 out of 10, which is 4/5. Make sense? Now, let's consider another example. Let's say we have a class of year 8 students, and there are 25 students in the class altogether. So we have 25 students. We have 18 doing some sport. 18 out of those 25 doing some sport. And 10 students doing music. No question, doesn't it raise any questions?
There's
No,
more
there's 28
people
instead of
doing
25.
So we have 28. What does it mean? We have
Some
some students do both. How many do both? We add this, we have 28 and minus 25 equal 3. Meaning that they doing all of them doing either sport or music or both. So there is no student who not doing anything. Actually, let's make that 2 students don't do no music, no
nothing.
do maybe something, but not music, not sport. then we will have 30 minus 25, so we have 30 minus 25 equals 5, doing both. How we can then represent this in the Venn diagram? We have sport, music. What we put here, doing not doing sport, not doing music? We have 2. How many do both? This is both. 5. Here we put sport only. How many do sport only?
13.
13. 18 doing sport, but out of those 18, 5 doing both. So 13 doing sport only. How many doing music only? 5. Makes sense how we completed this Venn diagram. Yes?
Why don't you take 30 minus 2 and then you do 28?
Okay, if you do 30 minus 2 and then minus 25, and then we do the same thing. Now, let's represent the same information using probability table. Probability table is, we put here sport, and when I write S dash, what does it mean? S
Not
dash?
sport.
Not sport. This is a complement S, which means not sport. And music, not music. And here is a total, will be total. Total we have 25 students. Sport, we have, how many do sport? In total, 18. How many do music? 10. Now, here will be music and sport. We have 5. This will be me doing music only. Music but not doing sport. We have 5. You see, these numbers adds up to 10. We have all together 10 students doing music. 5 doing also sport, 5 doing music only. Now, doing sport but not doing music. 13. And you see that adds up to 18. 5 doing sport and music, 13 doing sport only, altogether 18 doing sport. And we should numbers here adds up to 25. So what number should be here? We have number 7. And this should add up to 25. So 15. And what should be here? 2. Those students, they're not doing music and not doing sports. This is a probability, it's called probability table. We can present probability using a Venn diagram, we can use probability table. Now, this is a numbers, but we also can calculate probabilities associated with them. So what will be probability of, if you randomly choose one student from the class, what will be the probability if that student doing both music and sport?
1/5.
5 out of 25 will be 1/5. So obviously 1/5. That will be 2/5. This will be 13 on 25. This will be 2 on 25. Because we're over 25, over total. This will be 15 on 25, which is 3/5, 18 25, and 7 25. This is a probability.
Wait,
Yes?
why did you minus 25 from 30 at the start?
Because we have, how many students we have in the class?
Oh, 30.
25.
Oh,
But if we add 18 doing sport, plus 10 music, plus 2, we got 30.
Oh, I understand.
But why do you add the 2 if they're not doing any?
No, we
They're
just,
gonna find the
They're
middle.
still part of the class.
because they're still part of the class, yes. Perfect answer, they're still part of the class. Now, can you help me to fill, if you have probability table, let's say we have A dash, B dash. By the way, probability of total here should be always 1. So we have part of the table will be filled. You will need to help me to fill what's missing. So this always 1. Probabilities adds up to 1. And we have, let's say we have here 0.3. We have 0.7. And we have 0.2 here. Now, can we fill now missing, and that's probabilities, because probabilities can be as a fraction, decimal, percentages. Can we fill missing numbers?
Yes.
What number should be here?
0.3.
0.3, yes, because they need to add up to 1. What number should be here?
0.4.
Yep, good. So what number will be here?
0.6.
0.6. So what number should be here? 0.1 and here
0.4.
0.4. So you see how easy is field probability table. That's all for today. Please like, subscribe and donate to help fight Russia and Hamas, support Ukraine and Israel.